All right, thank you very much. Thank you for the invitation. I'll just share my screen. I've got some slides, some pretty pictures to help illustrate it. I'll give you the short version of the 400 slideshow that I have prepared. Basically, yes, I'm interested in, and you'll come to understand why the spaceships might make a serious difference as I start to talk about it. This is the least serious topic introduction that I can give. It's got a formal name for the PhD thesis, but serious spaceships always makes a good impression. So I'm actually interested in what we're looking at illicit markets and people and groups that work within illicit markets. So I'm really interested in organized crime. So you can think of illicit markets as drug markets. Is probably the easiest example to think of, but there's many other illicit markets that operate. But basically looking at the premise that people tend to group together in these markets to occupy space, to extract resources. And these people, why we would care about that is because these people are more likely to commit a criminal offense. They're more likely to commit violent offenses within these illicit markets and interacting with these illicit markets. And they're also more likely to be party to a homicide, either as the victim or the perpetrator. And these markets themselves are what would be characterized by trust. So trust in the people that you're interacting with, trust in the people that you've grouped together with, trust in the transactions, your reputation, so either your reputation for violence or responding to violence, and your reputation for doing good deals and good trades within this, and when all else fails, violence. So, and also that within these sort of groups that respond to this threat, and that threat can be real or perceived. It doesn't need to be. And we have very traditional ways of measuring crime. We've got official data, which is basically what everyone understands as crime statistics. We've got victimization surveys, which talk to victims of crime, self-reporting surveys, which talk to the perpetrators of crime, and observational studies, which in criminology can be quite challenging to do because according to my ethics, I can't go out and rob a bank to study bank robbery. But each of these things have very separate kind of issues with them. And there are some very specific limitations to some of the things that we talk about when it comes to network science and criminal intelligence. That we end up with sort of very incomplete networks due to the fact that this is a covert behavior. People don't necessarily want to advertise that they're involved in the illicit market. It's inaccurate because of the covert nature as well. Sometimes what is observed and what's recorded is not an accurate representation of the relationships and people involved in these networks. And it's inconsistent. So it's not always consistently measured between jurisdictions, between police departments, between other ways of dealing with other entities that deal with organised crime. And there's also some problems with the data transformation. So some of the data that's collected about criminal networks needs to be transformed into something that looks like data that we can use for network analysis. They're very fuzzy boundaries. So who to include in the network and who to exclude from the network is quite difficult. The relationships aren't always as straightforward as they seem. One brother might be involved in organised crime, but the other brother wouldn't be involved in organised crime, but they are closely connected to each other. What is that connection valid? Is the family connection valid, or is one brother definitely separate from the organised criminal? And we also don't deal with network dynamics very well in criminology. We may have one sentinel event, say a homicide in August, and a retaliatory homicide that won't occur until maybe up to 12 months later. So what happens in between those two sentinel events can be quite difficult to observe. So I'm looking at an alternative approach, or proposing an alternative approach, and that's looking at virtual worlds, which is kind of a new way of understanding crime and the way that groups behave in these illicit markets. So what do I mean by virtual universes and virtual markets? Well, there are these other places where these self-organizing groups participate in the provision of goods and services for profit. And I'm talking about massively multiplayer online games. These are significantly more than 2 players. So we're talking hundreds of thousands of players in some case. And that these interactions happen in real time, and that the world that they exist in is online and persistent. That means that even if you're not logged in as an individual player, the world continues to exist without you. So if you think of traditional video games and traditional games, once you stop playing the game ceases to exist. And the key thing in all of this is that with the games that I look at is that they are player-driven economies, that these are economies where players are responsible for the majority of the goods available for sale in the game. They take the raw materials, they manufacture that raw material, and they sell and distribute that, all without much interference from the game itself. And these networks that have evolved in video games or in massively multiplayer online games actually have had some work done for us. They are established and validated in other disciplines. They've been used to examine actual social networks in human geography, epidemiology. There was a famous case where a game's what would be considered a disease in the game escaped the place where it was supposed to be and spread through the player base. And it's also been used for study of economics. People who play massively multiplayer video games with an economic basis, so with certain player-driven economies I talk about, tend to behave incredibly rationally within those games. So there are some benefits to this. It's much easier to see the crime event, which lets us look at the possibility of all the kind of events that may lead up to a crime, or the possible to see the opportunities before the crime occurs, to see the events that lead away from the crime event. So not just sort of like we now contract the victims and the offenders across, which can be quite difficult to do in the real world. We kind of need to acknowledge that these are real people in virtual situations. So you can think of this in some ways as agent-based modeling without the agents, replacing the virtual agents with real people. And being a virtual situation, we can control the information environment presented to the player. So it helps to be able to allow us to do natural experiments or do experiments within the game with the cooperation of game developers. So really the game is recording all these actions and movements of the players by its nature, but that's really good for us because we can get to see all those things. They're all recorded, which leads to this easier to see these aggregate patterns of crime that sometimes can be difficult to detect in the real world, which again leads us back to the idea that we can observe the criminal events. Oops, 2 minute slides. So I'm looking at a science fiction-based role-playing game, which is where the Spaceships come from. So this game has approximately 600,000 plus players subscribed to it. The average number of players per day is about 16,000, but it can peak out to about 60,000. So we're talking a player base roughly the same size as the Gold Coast, with the kind of like, if you think of it, actions per day through the CBD of the Gold Coast is about 16,000 people, which can peak to 60,000 people. The players are allowed to form groups within this, which are known as alliances. Once you get to an alliance group, they're able to occupy the territory, so that they're able to claim the territory for themselves, which gives them certain rights within that territory to extract resources and to control entry and exit. Alliances are formed of these smaller subgroups known as corporations. And it's these sort of like alliances and corporations compete for the in-game resources and the wealth which is found within inside these occupied territories. So you need to occupy the territory before you can extract wealth. And if you think of a drug market, a drug dealer has to occupy a particular particular location to be able to sell drugs. And the competition over these so-called drug corners can be quite violent, or these drug markets can be quite violent. Enough sort of talking, I guess, about the theory behind this. So realistically, we're looking for some kind of way of observing a covert behavior in a much more open fashion and a sort of more ethical and safe fashion. So this is what my network looks like. So I've extracted 1% of the data that I was able to collect, which roughly translates around about 2 months worth of data, around about 140,000 players, and around about 1.4 million events. This is all the edges. So unfortunately, because it's such a dense data set, collecting all the edges together with all the players in one place doesn't necessarily tell us much, but you can kind of see where, if I've colored the different groups, that are competing groups, you can kind of see where the competing groups interact with each other. And there's a broad sort of blob in the middle of people that sort of sit between some of these groups. So it's kind of not as informative as it could be. So what I've had to do is split that data down a little bit more. So looking at this kind of idea of hot spots and hot locations and hot individuals. So sorting the data by degree and looking at the top 5 players in this case, so hot individuals, and looking at sort of the patterns of behavior that they, and the patterns of, and in this case, this is the patterns of victimization. So the links represent people that they've attacked. So you can see that the sort of people are split into sort of 2 groups, the top group and the bottom group of 3. So the top group of 2 and bottom group of 3. And interestingly enough, those people are actually in the same alliances, the same sort of groups that occupy space. But you'll notice that there's some people trapped between those 2. That's sort of like a in the wrong place at the wrong time, or mutual threats kind of idea, but they don't make up much of the overall kind of way that violence flows within these networks. And I split it again, and so I was talking about those hot individuals before that belong to 2 sort of like 2 groups that are in conflict with each other. So I've taken an idea of looking at the co-offending graphs as well. So not just the victimization graphs, which is a directed graph, looking at the co-offending graph, which is an undirected graph. And you can see here that I've given the group an identity number of 288. So this is 724 individuals with 32,000 links approximately between them that can be split into around about 6 communities. And that compares with the other group, which is group 498, which is around about 1,096 players with 50,000 links between them, and can be roughly divided into 9 communities. But they are quite similar to each other in many ways, that there are between 3 and 4 core groups, which I guess on this particular, on the 498 graph, you can see is denoted by the heavy links, which are colored yellow, between this group at the top there that you can see. So they tend to interact with each other more regularly, and that most of the other people that are involved in the group are rather weakly connected to these core groups. So there's core groups that commit the most violence within the group that tend to be strongly connected to each other, and then there's people that are weakly connected that don't commit as much violence. And an interesting thing, I was trying to get a bipartite kind of representation of these graphs. So I ended up putting the 2 co-offending graphs on the same page to start with. And I found an interesting thing, that these 2 groups are actually linked together by one single player that changed sides in the middle of this conflict. So you can see that not that's very clear on this graph, but there's a green dot that sits between these 2 large groups that actually connects the 2 groups together because they changed about halfway through this. So about halfway through the 2 months that I've captured, they changed from one group to the other. And you can see that they actually changed from being linked quite strongly to one core group in one graph and one core group in the other graph. So it must have been quite a high ranking person that changed sides at that time. These are kind of the insights that I'm beginning to pick up. So I'm beginning to write this up as a paper as we speak. But that's it for the presentation.